To better understand, let's have one example of moving average process. This example is very easy. So suppose that in order to produce these random process, I just average them. So I add successive samples of your input divided by n. So it's kind of like very simple. So the L of Z is given by that. So this could be simplified. So you could see that this is equal to Z to the power of minus m minus 1 divided by 1 minus z minus 1. So you could simplify it. So it's kind of like expand. And now if you calculate z inverse of that, if you calculate L of Z and you multiply by L of Z by L conjugate of Z minus 1 conjugate. So from here you get the power spectral density Sx of Z, you get 1 minus Z minus M divided by M times 1 minus Z minus 1. So this is true if this expression is if Z is smaller than or equal 1, but for this one Z should be bigger than or equal 1. So like if you want to calculate this one, you get 1 minus Z to the power of M divided by M and then 1 minus Z. Now obviously if you want to calculate this one, you have to apply Z inverse, and in that case you have to use something like partial fraction expansion. So if you have forgotten this, you can go and revise your math. Now, so what we got in this expression, if you replace Z equal to e to the power j omega, you get Sxx of e to the power j omega, or power spectral density. So we get 1 minus this, so this will become 1 minus e to the power j omega times 1 minus e to the power minus j omega, and then times m, and then you write the rest of it. Remember that 1 minus e to the power minus j omega, you can multiply these by e to the power of j omega divided by 2, take it 2, and then multiply it by e to the power minus j omega divided by 2, because these and these simplify each other. And then you have for the second term here can go e to the power 1 minus e to the power minus j omega. Okay, so I put so this should be positive. So if you absorb this with this one and this one, you will see that this is equal to twice cosine of omega over 2, and this is also twice cosine of omega divided by 2, and so on. So simplifying that, you get this expression, so the power spectral density. So it's a sinc to the power 2. So if you want to plot it, you get something like that. And obviously, this is for one period from minus pi to pi, okay? But it's going to be repeated, it's periodic, because we are talking about discrete time random processes.